उनके हाथ में है रिमोट. Good afternoon, everybody. Today we are going to discuss a chapter, probability. It is the LAQ, question number 23 in your list. The chapter is probability. First 7 marks questions I'm going to explain. First, before going to discuss the question, let me give some formulas on probability. There are few formulas. The formula goes like this. If A comma B are two events, A comma B are two events, then P of A union B is equals to P of A plus P of B minus P of A intersection B. This is the first formula. By using this, we derive addition theorem also. When A and B are only two events, P of A union B is equals to P of A plus P of B minus P of A intersection B. Suppose if you have three events, A, B, C are three events, then P of A union B union C is equals to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. This is about P of A union B union C. Next, one more interesting. Suppose if A comma B are independent events, just events mean this is the formula. If A comma B are independent events, when the word independent is given, immediately P of A intersection B changes as P of A into P of B. So in the given question, we have to observe whether independent word is there or not. If independent word is there, P of A intersection B can be written as P of A into P of B. Next, P of A complement. Complement is denoted by either A dash or A complement. Is equals to, we can write 1 minus P of A. Generally, success plus failure is equals to 1. That is P of A plus P of A complement is equals to 1. Based on these formulas, today I'm going to explain a 7 mark question. First question is proof of addition theorem. State and prove addition theorem. This is a most important question. Every time this question will be asked either for 4 marks or for 7 marks. Let's go through the formula. We'll start the theorem. Yes. Theorem statement is heading addition theorem. Addition theorem. Question state and prove will be given. So statement we have to write. Statement is if A comma B are, you can write A comma B, or in terms of E1 and E2 also you can write. We'll go for E1 and E2. If E1 comma E2 are two events, then prove that P of E1 union E2 is equals to P of E1 plus P of E2 minus P of E1 intersection E2. This we have to derive as the addition theorem. For this, proof goes like this. By taking two cases, we are going to derive this theorem. One is E1 intersection E2 is, here the third point is E1 intersection E2. E1 intersection E2 is null set. The second point, E1 intersection E2 is not a null set. So by taking two cases, we have to derive first case 1. In proof 1, what is given? Given that E1 comma E2 are two even. So first, case 1. Case 1. What is case 1? If E1 intersection E2 is equals to null set. If you draw the diagram, this is E1 and this is E2. If you observe, is there any common area between E1 and E2? There is no common area, both are different. So E1 intersection E2 is equals to what? Null set. By taking this result, we have to prove this. E1 intersection E2 is equals to null set. Now, by the union of axiom, P of E1 union E2, by the definition, what is union? Union means plus. P of E1 union E2 means we know only P of E1 plus P of E2 as of now. P of E1 union E2 by the definition is what? P of E1 plus P of E2. But what we have to prove, E1 union E2 is equal to something else we have to prove. So here is equals to P of E1 plus P of E2. I am writing extra minus 0. So P of E1 plus P of E2 minus 0 is nothing but what? P of E1 intersection E2. So we got the statement correctly, right? So P of E1 union E2 is equals to P of E1 plus P of E2 minus P of E1 intersection E2. So with this, case 1 is proved. Case 1 is simple. What we have taken? There is no common between E1 and E2. It means E1 intersection E2 is equals to null set. By taking that P of E1, so here if you want, you can add one more. E1 intersection E2 is equal to null set implies P of E1 intersection E2. Probability of E1 intersection E2 is equal to probability of null set, always 0. By taking axiom of union, so what we have to write? P of E1 union E2 means P of E1 plus P of E2 minus P of E1 intersection E2 instead of take 0. So here by the axiom of union, you can derive this one, first part. Now, move to the second part, case 2. Case 2. Case 2, what it is? If E1 intersection E2 is not equal to 5. Not equal to 5 means there are some common areas in that. So if you take with the theorem, if you take with the diagram, this is E1 and this is E2. Name it E1 and E2. If you observe, there is a common area between E1 and E2. So this green part is E1 intersection E2. And another one, this orange lines are what? There are two different shaded parts. What are they? The first shaded part, horizontal line. Horizontal lines are called what? E1 intersection E2. The second shaded part, vertical line. The vertical lines is called what? E2 minus E1. The main thing we have to observe these two. Horizontal lines are E1 intersection E2 and vertical lines are E2 minus E1. Now, focus on the diagram. Union of these two will be what? Union of E1 intersection E2 and E2 minus E1 is what? Union of E1 intersection E2 and E2 minus E1 is what? This complete part, right? This complete part means E2. So, by the Venn diagram, E2 can be written as E1 intersection E2 plus E2 minus E1. Agreed all of you this? E2 can be written as E1 intersection E2 plus E2 minus E1. Apply probability. P of E2 is equals to P of E1 intersection E2 plus E2 minus E1. Now again, by the axiom of union, P of E2 can be written as union plus means what? P of E1 intersection E2. Separate it. Otherwise, here you can write instead of plus union symbol. In problem, we have to use union symbol. P of E1 intersection E2 union E2 minus E1. So if you remove this union, it will be plus P of E2 minus E1. Take it as equation 1. Keep it aside. Or else, you can write one more step here. That is, P of E2 minus E1 value we want to find out. P of E2 minus E1 we want. Send E1 intersection E2 to the left side. So it is P of E2 minus P of E1 intersection E2. Half of the part we got. The remaining half. For remaining half, again what you have to do? Again take the diagram. See, diagram number 3. Take this is E1, take this is E2. E1 and E2. As we discussed, vertical lines are what? E2 minus E1, right? And horizontal line, in previous question, horizontal line is E1 intersection E2. But here, what is the horizontal line? Observe carefully. If you draw the diagram, horizontal line is nothing but E1 here. And vertical line is nothing but E2 minus E1. Again, a union of both shades. Horizontal line and vertical line union means from here to here is called what? E1 and E2 together. Therefore, here what we have to write? By the Venn diagram. E1 union E2 can be written as what? E1 union E2 minus E1. Apply probability. P of E1 union E2 is equals to P of E1 union E2 minus E1. Expand union. So it is P of E1 plus P of E2 minus E1. But from equation 1, we have E2 minus E1 value. Substitute is equals to P of E1 plus P of E2 minus E1 is what? P of E2 minus P of E1 intersection E2. P of E2 minus P of E1 intersection E2. Therefore, what is the result? P of E1 union E2, we got it as P of E1 plus P of E2 minus P of E1 intersection E2. Like this, you have to derive the addition theorem. So this is how the theorem goes. Based on two different cases. One is E1 intersection E2 is null set. That is case 1. It is simple. Just apply the union means plus, then expand the union formula. You will be getting P of E1 union E2 formula. Then case 2 is a little bit lengthy. By taking, there is a common area between E1 and E2. Applying the union concept again 2 times, we will be getting that. Just go through this. Next question. Question number 2. This is about a 3 event. The question is like this. A, B, C are 3 newspapers from a city. A, B, C are 3 newspapers from a city. Three newspapers from a city. In this, 20% of the population, 20% of population read A. 20% of the population read newspaper A. 16% of the population read B. 14% of the population read C. 8% of the population read both A and B. 5% of the population read both B and C, or read both A and C. 4% of the population read both B and C. 2% of the population read all 3. 2% of the population read all 3 papers. Now, what is the question? What is he asking? Find the percentage of the population who read at least one newspaper. Question is, find the percentage of the population who read at least one newspaper. Who read at least one newspaper. This we have to go. Mute. Just go through the question. Let me know the idea how to do. Yeah, solution. Given that, what is given? A, B, C are 3 newspapers in a city. A, B, C are 3 newspapers in a city. So different percentages are given because everybody can't read all 3 newspapers. Some can like A paper, some can like B, some can like C, some can read both A and B, some B and C, some C and A. Some people are there who wanted to read all 3 newspapers also. Further, different combinations are given here. Given that probability of newspaper A is 16%. If we remove this 16%, it is 16 by 100. Don't simplify, let it be 16 by 100. And probability of B newspaper is 14%. 14% is 14 by 100. And probability of C newspaper is 8%. That is 8 by 100. Next, probability of both A and B read. Probability of both A and B read 8%. Once again, I am coming back to the question. Probability of A reads 20% is given. So it is 20 by 100. Probability of B reads 16%. It is 16 by 100. Probability of C reads 14%. It is 14 by 100. And probability of A and B reads 8%. 8 by 100. Probability of B and C read 5%. It is 5 by 100. And probability of C and A read 4%. It is 4 by 100. And probability of all three means A and B and C, and means intersection, or means union here. So all three means A and B and C. 2% people will read. We can write it as what? 2 by 100. Now, what is the question? Find percentage of the population who read at least one newspaper. So we want probability of read at least one newspaper. At least one newspaper. How can we put it as a formula? At least one ka concept, either A paper or B paper or C paper. All three bole to A and B and C. And means intersection. So at least one means either A or B or C. So it is A union B union C. So the formula for A union B union C is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. By substituting all values here, we will be getting the solution. So come on. P of A is 20 by 100 plus 16 by 100 plus 14 by 100 minus 8 by 100 minus 5 by 100 minus 4 by 100 plus 2 by 100. If we observe, all denominators are same. No need of cancelling. Directly take the common denominator. It is 100. So that is 20 plus 16 plus 14 minus 8 minus 5 minus 4 plus 2. So simplify. 20 plus 16, 36. 36 plus 14, 50. 50 plus 2, 52. So positive terms are 52. And negative term, minus 8 minus 5 minus 13 minus 13 minus 4 minus 17. 52 minus 17, it is 35. So 35 by 100. Question is in percentages. So we can write 35%. So probability of reading at least one newspaper is what is the percentage? 35%. There is second bit also here. Second bit. Probability of read only newspaper A. Percentage of the population read only A paper, A newspaper. You can say only A newspaper 20% is given. Now what is there new in this to find? But A paper is 20% is given, but some combinations are there. A and B can read, A and C, and all three can read. In that also A is there. So that is why we have to take only A newspaper means P of A and subtract the combinations with A. P of A intersection B minus P of A intersection C and add all three. P of A intersection B intersection C. So this is 20 by 100. A intersection B, how much we have? A intersection B is 8 by 100. A intersection C is 4 by 100. Minus 8 by 100 minus 4 by 100 and all three we have 2 by 100. Here also LCM is same 100. 20 plus 2, 22 minus 8, 4, 12. 22 minus 12 is 10. 10 by 100. So 10% of the population read only a newspaper. So like how we have to find it. Suppose read only B newspaper he asked. So what to do? P of B minus the combination you have to write. So like how we have to find out the different combinations. So go through it. Next question. We'll move to the next question. This is also same type, but a little difference is there. Here ABC are 3 events. ABC are 3 events. Such that some values are given such that probability of A is equals to 0.3 and probability of B is 0.4 and probability of C is 0.8. Probability of C is 0.8. Probability of A intersection B is equals to 0.08. And probability of A intersection C is 0.28. And probability of A intersection B intersection C is 0.09. And one more is given, probability of A union B union C is greater than or equal to 0.75. Then show that P of B intersection C lies in the interval 0.23 to 0.48. Lies in the interval 0.23 to 0.48. This is also based on P of A union B union C only. Solution. First write the given data. What is given? A, B, C are 3 events. Given A, B, C are 3 events. So given data is P of A 0.3, P of B 0.4, P of C 0.8, P of A intersection B 0.08, P of A intersection C 0.28. P of A intersection B intersection C 0.09 and P of A union B union C greater than or equal to 0.75. This is the given value. We have to find out the interval of P of B intersection C is 0.23 to 0.48. Before going to that, we know the random sample space is always 1 or less than or equal to 1. So, we know P of A union B union C is less than or equal to 1. But what is given? Given that P of A union B union C is greater than or equal to 0.75. By combining these two, take this is equation 1 and take this is equation 2. From 1 and 2, combine both of them. From 1 and 2, if we start writing from 0.75, 0.75 less than or equal to P of A union B union C, which is less than or equal to 1. So 0.75 less than or equal to P of A union B union C formula, P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C, which is less than or equal to 1. All values we have, so substitute 0.75 less than or equal to P of A 0.3 plus P of B 0.4 plus P of C 0.8 minus P of A intersection B 0.08 minus P of B intersection C. We don't know, so write B of B intersection C as it is. Minus P of A intersection C is 0.28 and plus P of A intersection B intersection C value is 0.09, which is less than or equal to 1. Now, 0.75 less than or equal to, add the positive term 0.3 plus 0.4, 0.7, 0.7 plus 0.8, 1.5, 1.5 plus 0.09, 1.59. Take the negative term, 0.08 minus 0.28. Add both of them. It is minus 0.36. Minus P of B intersection C as it is, which is less than or equal to 1. Now, 0.75 less than or equal to 1.59 minus 0.36. If you want in rough column, you can try 1.59 minus 0.36. 3, 2, 1. It is 1.23. So 1.23 minus P of B intersection C less than or equal to 1. We want only P of B intersection C. So subtract both the sides with 1.23. So this becomes 0.75 minus 1.23 less than or equal to minus P of B intersection C less than or equal to 1 minus 1.23. So 0.75 minus 1.23. So 1.23 is bigger number minus 0.75. If we subtract, it will be 8, 4. So bigger number is minus. So minus 0.48 less than or equal to minus P of B intersection C less than or equal to 1 minus 1.23 is minus 0.23. Both the sides remove minus. If we remove minus, 0.48 less than becomes greater than P of B intersection C greater than or equal to 0.23. Right in reverse order. 0.23 less than or equal to P of B intersection C less than or equal to P of 0.48. If we observe P of B intersection C is lying between 0.28 and 0.48. Therefore, we can say the interval of P of B intersection C is 0.23 to 0.48. Therefore, P of B intersection C lies between 0.23 to 0.48. This is how we have to write, we have to prove. Take the given contents correctly and apply into the formula. Easily we will get the solution. Changing this. Next, I'll give one more question to the homework. Just practice it. If you do not get, just ask me. A simple question. If ABCR, three horses in a race, ABCR, three horses in a race. This is also one of the important questions. The probability of A to win the race, is twice that of B, and probability of B to win the race is twice that of C, What are the probabilities of ABC? Question is, what are the probabilities of ABC? To win the race. ABC to win the race. There is one more bit. Also find the probability that A loses the game. Just try this question. If you do not get, we'll continue the class tomorrow. Thank you. ఏమన్నది